Hello. This is another edition of 3D Printing News Unpeeled, live with yours Peels, courtesy of 3dprint.com. So I'm the executive editor of 3dprint.com and also lucky enough to be the vice president of consulting at Smart Tech Analysis. And I'm going to give you today a short news roundup of the most relevant 3D printing news of the day. And today we've got four items for you today. First, we've got the Nevermore Recirculating Active Carbon Filter. So this is an active carbon filter made for FDM systems, and that's been designed with 3D printing in mind. It comes out of the Voron project, which is like a project to make a better 3D printer. This is kind of like a side catch of that project. And now it's been adapted to the point where you could integrate it into more FDM systems if you want. It's a recirculating filter, so it sits inside the printer build chamber. On the bad side, that's going to, be a little bit of a problem, and depending on your printer, it's going to change your build volume, or stuff is going to knock into it. It also deals with VOCs, but ideally in a future iteration somewhere would also have a HEPA filter, of course. It's made, one of the interesting things about it is, if you look at here, it's a kind of expanded design of all the constituent parts. First off, it looks really nice, I think. And it's made specifically through 3D printing to aid 3D printing. And we do a lot of additions on the machines, and people are making enclosures, but a lot of like this is a cut above a lot of the 3D printing add-ons and things we see. And it is solving a fundamental problem that we have, especially if you're going to be doing this in a classroom, if you have small children, or if you care about your own health, and very especially if you're losing ABS or TPU or flexible filaments, or glass-filled or carbon-filled filaments, this could be a big issue for you, especially if you're running it every day in a room with low circulation or ventilation. Again, if you have 10 room changes an hour, usually this kind of thing isn't a problem for you, but we can't always guarantee the room we're in is going to have enough air changes per hour, and if it's well ventilated enough and stuff like that. So I think, especially with like flexible filaments and stuff like this, these kind of filters are at one point going to be the norm. And there's no real solution. There's some cabinets out there. There's some other solutions, but there's nothing really definitive for this. So this is really a market. If you're looking at the 3D printers on the market now, having a similar filtration system that is made using 3D printing and then also has a HEPA filter would really be a big deal. We're seeing more and more industrial 3D printers using these systems and more pro systems. And people at the home office type of thing are kind of experimented with it, but I definitely think in an institutional environment, this should really be the norm. So it's a bigger news item, I think, than we think. Just to tip you guys off, there's a big business opportunity out there. The next thing is the Filament. Filament is a company that is for 2 months doing a pilot project where they place near beaches in Tallinn in Estonia. They're going to place these bins to collect cigarette butts. Now, cigarette butts, we've probably all seen them on the beach and stuff. But what I didn't know is what these Filament guys are saying is that one single cigarette butt can contaminate 1,000 liters of water. And sometimes they can go on and stay for a very long time in the oceans. So they're trying to come up with this. And the solution they have for this is, well, it's very intriguing because they haven't disclosed how they're going to do this. What they want to do, or they're going to do, is they're going to collect these cigarette butts and they're going to use this cellulose acetate material. And then that's going to be found in the cigarette butt, and they're going to then make it into a 3D printing filament. Again, I don't know how they're going to do this exactly. They're a bit light on the details so far. The idea then is that we're going to get a compostable material. So they're doing not only upcycling these cigarette butts into something reusable, a filament, but ideally, at the end of the day, compostable is also what it's going to, with the parts being made with this. And compostable actually is not something random. You can just say compostable. Actually, you have to adhere to certain standards on what compostable means. So it has to degrade in 28 days or something like that, depending where you are. So this would actually be a really big deal. I really like this as a project. It seems I'm very optimistic about it. Let's say still don't understand how they're going to do this, how they're going to make filament out of it, but I do think that this kind of like action-based, kind of like people are you're activating people and you're gathering a useful material, and maybe if you could do exciting things with it, then that would be I think quite notable. This kind of stuff, and we could expect more of it in the future. The next news is that Indian startup Skyroot Aerospace has raised 51 million US dollars. which I think is fantastic news. First off, like nearly all the new space, the commercial space activity we see, the venture activity, the startup activity is in the United States of America. There's very little going on in Europe, very little going on in Japan. There's some going on in China, but it's very focused on China specific. And even in Europe, I mean, there's Swiss 212, there's, I don't know, there's only like a couple of companies that I'd be pressed to really know that are doing things in Europe. And typically, so it's nice that there's an Indian company that is going to tackle this, and they're getting a fair bit of money to do this. I mean, 51 million would be a lot of money in the 3D printing industry, but in the space industry, it's not a lot of money. So, but still, it's a momentous achievement. The company in this kind of market can raise this kind of cash, and the opportunity that they're going for is also one that really makes me very enthusiastic about this company. So why are they here on the 3D printing news? Well, they make a 3D printed cryogenic engine. This made 95%, or they're making this, the production time is 95% less than if they would use traditional methods because they're using 3D printing. Now, we also know that they're going to be able to consolidate parts. We know they're going to iterate faster using 3D printing. We know they can save weight, and we know they can get optimized things. Optimized structures. So these are the reasons why 3D printing is so is powering all of the commercial propulsion space projects that we see so far being powered by 3D printing, using 3D printing extensively because these reasons. It's just cheaper, it's faster to iterate, we can get less parts, we can save weight. And what's most important to these guys, of course, they're faster to market. They get there faster, they launch faster, and they iron out their problems faster. So this is why, you know, the commercial space industry is quickly becoming one of our biggest markets, I think. And so we should be following this very quickly. And you should really read Vanessa Listek's articles on space. They're very insightful, and I love reading them myself. So what Skyroot is doing, because I don't know if you noticed, but a lot of these space guys are kind of like cutting out a little vertical, trying to claim a little bit of a space here. And their space is around low Earth orbit satellites. And they're focusing on having like 815 kilo payloads, but being able to deliver them at multiple and different orbits. So that means they could take relatively small, well, we're not talking like the giant spy satellite, you know, bus-sized kind of satellites. We're talking, you know, maybe CubeSats or larger or kind of small commercial satellites. Now, the way I like this is they're kind of limiting themselves in the payloads they can take, but through miniaturization, advancement of computers, we're going to expect like these small payload satellites to be able to do so much more in the future. So I like this. The other thing I like about this is they're focusing on democratizing launch verticals for this low Earth orbit satellites, right? And they say they expect that over 20,000 of these will be launched. Other people say statistics that satellite launches generally are going to increase from 4,500. So if they optimize their launch vehicle, their engine package, the rocketry, everything for this low Earth satellite, and then make it possible to repeatedly and reliably launch several different satellites into several different orbits every time, it'll be a remarkably cost-effective thing. Now, the other thing is the legacy of being in India. With India's space program, I still don't know if this is true, but somebody told me once that India's space program cost about as much as the movie Gravity. Generally, what I know 100% to be true is that India not only has a very exciting cutting-edge space program, it's doing this in a lot more frugal way than a lot of other countries are doing it, which means that maybe Indian space startups can be more frugal as well and become much more bang for your buck than American startups, use a lot more engineers to solve a lot more problems, and maybe out-engineer the Americans, which would be a very exciting thing. So far, their Dawan 1 engine has an awful lot of 3D printed components, and that makes them a very important player in our market as well. So Singapore's GIC led this round. The company's been around since about 2018, and 51 million doesn't get you very far in space, but maybe these guys can frugally engineer their 3D printed rocket engines and rockets into a leading position in 3D printing. That would be very exciting, I think, for all of us. The number one piece of news is recycling again. So this is a project from Washington State University that turns PLA into resin. Now, I think more of us are finding out that PLA is not exactly the dream material we all thought it out to be. It uses about 7 liters of water per kilo of PLA. It's a foodstuff material, so you know, it would theoretically make food prices rise or be sensitive to food prices if we use it at scale. So and on the one hand, we do expect in the future PLA to be manufactured from food waste or from agricultural waste, so that would make it a lot more sustainable. But I think everybody right now knows that recycling PLA is very difficult. The mechanical properties degrade very rapidly and are also kind of semi-unpredictable or less predictable than one would like. So it's more difficult to recycle, let's say mechanically or otherwise, than, for example, ABS or other materials where you just mix in 30% virgin material and you get kind of a slightly degraded but still very useful material. Also, composting PLA is not possible, and you need what the researchers at Washington State University say that sometimes it could last for 100 years. So, but just because it's made of corn doesn't mean it's a panacea, but it may very well be. Now, so what these researchers have worked on is saying, under Professor Yinwang Zhang, is they've managed to take PLA, right, which is using 3D printing and also in packaging material and all this. And a lot of people are looking at it as a huge volume material in the future. Only, for now, it's only used 300,000 tons, which is not a lot worldwide as plastics polymers go. What he's done is, or they've done, actually, there's a team behind this, of course. And here he is, Jinmeng Zhang. And what they've done is something really remarkable, I think, really. They've developed a catalyst-free method using amino ethanol in 2 days, break down PLA into a monomer, right? Now, breaking down a polymer into a monomer it can be done, but often it's very energy intensive, or it's very complicated, or uses lots of different materials or really complex steps. And that keeps these things, a lot of these revolutionary things that you see coming out, they're not industrialized because they're just too expensive. So now they're saying that they have a relatively simple method that doesn't use a ton of energy, that doesn't use a bunch of really expensive materials or really expensive equipment, that can take PLA and take it into a monomer in just 2 days. And that's great news for the 3D printing industry, because that means that we can really recycle PLA in a very meaningful way, not in a kind of like way that a lot of other materials are recycled now, where we kind of basically downcycle, but in a really meaningful way, because the monomer is where you start up in the first place, and you can make that up into pretty much anything. And the team here at Washington State University has definitely shown us that, because what they've done is they then turn this monomer into a photopolymer material, which can be made for 3D printing. The beauty of this is that the photopolymer materials, of course, are the resin prices are from, let's say, $70 a liter to like $800 a liter. So it's a very high value application for this, and it really proves that you can take this used up FDM material extrusion material, and turn it into a very high value photopolymer material. So if we're looking at this from a financial standpoint, this could be a very exciting startup. But I think startup or commercialization is something in the works here, because they're really looking at the IP and looking at the different considerations in terms of patenting things and all that. And what's more, they also want to do this process for PET, and PET is an extremely large volume polymer compared to PLA. So in that sense, there's maybe more value to be unlocked in the way forward. This is, I think, a remarkable piece of research, and one I did not expect, to be honest. Yeah, I think very exciting for everyone involved. So thank you so much for listening to us today. My name is Joris Peels, and this was 3D Printing News Unpeeled. Have a great